Vad säger du? Aha, okej.
Okay, I think it's time to start with today's lecture. And today there are two main things that we will learn about. It's basically the main thing is the same. When you write a program, so you often have problems in your program. So you might have errors in your programs. So if something goes wrong, and then to deal with this kind of problems that can happen when you execute your program, Java and most of the other programming languages provide you with an opportunity that you can handle those errors at runtime. So, and the mechanism that we use in Java to deal with the problems and the abnormal conditions that could happen at runtime. For example, if user enters an invalid value that your program cannot handle. One of the common example is like division by zero, which is not a defined operation in mathematics, but when you allow a user to do a division operation, so it's totally up to user that what kind of values. You cannot control a user to enter a value. Or for example, if a user wants to, if there is a program that is reading data from a file, but for some reason that file doesn't exist on the client system, so in that case you cannot hard code it. So this, and also if there is some other resource, like a program is looking for a printer or some other device for communication, and that device all of a sudden it stops working. So it stops responding, so you cannot access that resource. So these kind of conditions, we call them like abnormal events or unexpected things that can happen. It's like exceptions, okay? And the same keyword we use in Java, like the problems that can happen at the abnormal conditions, which are not really expected. Of course, when we say that they are not expected, it's not exactly literally the same, because we expect them, that this can happen. That your program, of course, you have written it, you have tested it for a number of specific scenarios, but it's really hard to write a program that can handle all possible kind of input values. Depending on different users, there could be, different combination. Our user can be creative and innovative, and he can come up with some stupid value that can crash your program. So to deal with this kind of situations, Java provides us with the exception handling mechanism. So through which you can anticipate, and you can program your code in a way that it can identify this kind of abnormal conditions, and then you can write a code, a handler code that can catch that exceptions, and then it can do actions to handle that exceptions. Okay, so we will learn about this exception handling mechanism, and then a related concept is software testing. So when we read about software engineering or software development, so we know that there are different phases like requirements and design and implementation. So programming or writing a code is one of the software development activities. A related activity is software testing. So in today's lecture, we will talking about these things. So we'll first start with exception handling, and then in the later half, after the break, maybe we will talk about how to do unit testing using the Java code. So as I said in the beginning, exception is like something, an abnormal event or any unexpected condition that can happen at runtime when you execute your program. So basically, in simple words, you can say that the exception, they are like runtime errors. So when you execute your program, so there is an example given over here. So for example, and they are, when we call them that they are runtime problems or the runtime conditions, so it means that when you are writing a program, maybe you don't find them. So it's not like something that is checked by a compiler. Okay, so for example, we have a syntax errors. So if you write a code that is not okay according to the Java instructions or the Java syntax, then your compiler will complain. It will point to you like there is if you forget, for example, if you forget a semicolon at the end of a variable declaration which is needed, your compiler will immediately tell you that something is wrong over here. But in case of, for example, if we look at a class over here, so we have an example class here with the name of exception demo, and we just have two methods here. We have a main method, which is a starting point, and then we have the divide method, so which is basically taking two input variables, two input arguments, and then returning us the result of the division. Okay. If you see the values we are passing here are like p is equal to 7 and q is equal to 0, and we are using these two variables for the division. So if you see that here in your program, there is no problem. Your program looks fine. However, when you try to execute it, when you run it, you get an exception. You get an error at runtime. Okay, so the exceptions, in simple words, these are like the runtime errors, the runtime problems in your program. Okay, and whenever you are a program, when you execute a program, and if there is some exceptions, if there is some problem, so on the line of the code where the problem happens, your program will stop execution, and it will not be able to, all the remaining instructions will not be able to execute. So for example, here in this case, we know that when we execute a program, it starts from the main, so the first, and then it executes the instructions one by one. So here it's fine, but when you call this divide method, and it goes over here, and on this line it generates exceptions, and you can find it over here in the method over here. So you can see that exception in thread main java.lang.arithmetic exception division by 0. Okay, and it also points you the line number where the like for example exception demo Java, and this 13 is the line number. Okay, and then you can also see, but since I have changed this lines number now, so you can rerun it again. So now it says line number 16, and it highlights that okay, you have a problem on this statement. Now for example, if I change this value to something like 10, it's fine. So if I run it again, in this case there is no problem. So this statement now, because the operation was okay, there was no problem at the runtime, so this statement got executed, and we got the result as a result of the system.out.println. But when there is something that is not okay for the program, in that case, the Java runtime, the JVM, with the JRE that runs your program, it will, this is not, the compiler does not find this error. So, okay. So, if compiler has identified this, it would have told you when you was writing or compiling the code. But in this case, the problem occurs when you run it. Okay. So, that's something, an important thing to remember about exception. They are like runtime errors, and they are the conditions that can happen at runtime. And if you look at how now here, we have not written anything special to handle this error. Okay. When you have not written anything special to deal with this kind of errors, by default, the JVM will provide you with the default exception handler. So this message that you get in the red, this is from the Java default exception handler. And by default, it will provide you with some informative string text. So for example, now it tells you why this exception has been thrown due to arithmetic problems. So problems that is related to your mathematical operations. Okay, so and then it also gives you some idea like what is the cause, what is causing this, why this problem has happened. Okay. And also, it also gives you the stack trace. The stack trace means like it gives you if a problem has happened in a method, first of all, it will try to find an exception handler in that method. If it could not find the exception handler in that method, it will go back to the method which calls it and tries to find it in that method. So for example, now the problem we have, the root cause is here in the divide method. Okay. So at first it will look if there is some exceptional handler defined in that method. If there is some exceptional handler found in this method, it's fine. Then it will not look onto the method that calls it. But if nothing found here, then it will go to the method who calls this. Okay. So the divide method has been called in the main method. Okay. So if you look at over here, at first in the first line you see the problem description, why this problem has happened. Then in the next step, it gives you the method divide. Okay. But there was no exception handler defined in that method, so it tried to find it in the main method. So it gives you the complete call stack trace. Okay. So this method, the problem was in this method, but it did not have any code to handle it. So it go into the method that calls it. So if you have 3 methods in a hierarchy, like method A calls B, and B calls C, C calls D, and so in that case it will first look it in the method D. If nothing found in the D, it will go to the C, back to B until it goes onto the root. And if nothing has been found in the whole hierarchy, then it will use the default exception handler. And so the concept of exception is quite simple. Okay, so these are the runtime abnormal conditions that can happen in your program, and then those conditions can disrupt the flow of your program. Okay, but there are 2 major kinds of exceptions, because exceptions are kind of errors. Okay, some of the errors, they are too much severe that we cannot control them. For example, if there is a problem with the hardware resource, you cannot write an instruction that can fix that problem. But then, if it's something related to that can be handled, okay, if the file doesn't exist, yeah, maybe you can write something that can maybe create a file. So in Java, we distinguish between 2 kinds of exceptions. One we call them checked exceptions, and another one is unchecked exceptions. The difference between the 2 is, for the checked exceptions, the Java compiler ask you to provide an exceptional handler in the form of try-catch. We will see what the try-catch are. Or you either have to specially specify that through using the throws keyword, that in this method there is likely an exception is going to happen. You understand what I mean? So we have a checked exception. These are the exceptions that are checked by the compiler itself, that the compiler forces you to provide either a try-catch block to handle that exception, or you have to declare that this method is likely to throw an exception. On the other hand, there are some exceptions, there are some kind of exceptions for which the compiler doesn't even care. It doesn't check them. So these kind of exceptions we call them unchecked exceptions. Okay, and so the example of the unchecked exception is like, for example, null pointer exception. Okay, so you can do much about the null pointer exceptions, and the same is like arithmetic exception divided by 0. So, but if you look at both exceptions and errors, they are implemented in Java as classes, and when there is something as a class, so it means that they are treated as an objects, and in the objects you wrap the useful information that can be used to handle those kind of exceptions. So we have basically in the exception class hierarchy, the parent class is the throwable class. So it means that all the exceptions that are thrown in your program, they are subclasses of the throwable. They must be derived or extended. You can write your own exception classes. If you have a kind of a situation that cannot be that cannot be handled through the exception classes provided by the Java API, then you can write your own exception class. And to tell the Java compiler that this is an exception class, you can inherit it from the throwable, or maybe some of its subclasses. And on the second level, we have two major distinctions. One is the exception class, and another one is an error. So error represents something which is more severe, and that cannot be handled at runtime. So that are maybe not likely to be handled. And then there are also like runtime exceptions. These errors and the runtime exceptions, they are, if a class belongs to an error class or the runtime exception class, then Java compiler will not ask you to explicitly provide the exception handler for that. You can write a code that involves errors or the runtime exception classes without providing an exception handler. But for the all other classes that are subclasses of basically exception class, you must have to provide an exception handler. So for example, file not found exception. So you can see, for example, we have seen an example for one kind of exception, which was like arithmetic exception. Here we have not provided any exception handler, and the Java compiler did not care about that. But if we are reading the data from the file, okay, we have another class, and in that class we try to read something from this file. This is just any example file. You can use any example file, okay, and we use the file API, okay, to read from that file. However, and I'm using the scanner class to read data from this file, and the scanner is a utility class provided by the Java API. You can read about this, what kind of operation you can use. Normally for the input-output operation, we use this scanner class. So, and if you see that, I have used a special try and catch mechanism when I am reading the data from this file. If I comment these lines, and then I just comment this block as well. So now if I go here, where I'm trying to open the stream on this file, you see that the Java compiler has started complaining. It says that undefined exception type file not found exception, and it suggests you two fixes. Either surround it with the try catch or throws declaration. Okay, so basically in Java we have two mechanisms to deal with the exceptions, to handle the exceptions. So the one is through the try catch, and the finally block we will see how we can use them. And in the if you want to define your own code, you will have to use the try catch blocks. So the catch block will give you an opportunity to write your own exception handling code. But sometimes you don't want to write an exception handler by yourself. You want you leave it, the exception handling mechanism, to the clients of your code. If you have defined an API, if you have written an API, but the exception handling for that API could vary from one client to another client. In that case, you just specify that this code has a tendency, it has a likely that there could be this kind of exceptions. So you just point out that this kind of exceptions can happen, but you don't specify the code how these exceptions should be handled. So in that case, you just mark them using the throws keyword. Okay. So how do you use the throws keyword? So in the method signatures where exception can happen, for example, we are reading now this file in this main method. So it means that there can be file related exceptions in this main method. I don't want to define, I just want to mark out that there can be a chance of exception, but I don't want to provide a code to handle that exception. In that case, you just use the throws keyword and specify what kind of exception it could be. So you can write exception, which is a parent class, okay, but that's not kind of a recommended thing, because then it's like more generic. So maybe you should try to specify the exact kind of exception which can happen over there. So maybe instead of writing a file, you should like file not found exception. Okay, so that I just needed an import statement to import it. So it means that if you have an exceptions, so you can either, so this is what I want to show you, the difference between checked and unchecked exceptions. So if it's a checked kind of an exception, then you must have to provide either the try catch block, or you have to declare it that this kind of an exception can happen over there. But on the other hand, if it's like an unchecked kind of an exception, so for example, like we have seen in this operation over here, then you can even not ignore it or maybe show it, no, sorry, like division by 0, then you can just do it without using the try catch or even the throws clause. So these are just some basic facts given about the exception handling in Java. So all the errors and exception conditions are treated as an exception in Java, and you can just read about them, and if there is a problem, you can just put the question on the model. So, and that's this structure. When we talk about exception handling, the code that we want to write for the exception handling, we can write it using try and catch statements. Okay, and the try block, the catch block, this is basically it. This block is used to write a code that can handle the exceptions, but it cannot be used alone. It must be used in combination with the try block. And the try block, in the try block, we put the code where we expect an exception, where an exception could be, if you have a code that is likely to generate or throw an exception at the runtime, then you must have to write that code inside the try block. This catch block which will be always be used together with the try block. You cannot use it alone. However, it's an optional. You can use a try statement without a catch block, but in that case you have to provide the finally block. The difference between catch and finally is that the finally will get executed always, whether there has been an exception or not in the try block. But the catch block will be executed only when there is an exception that hasn't happened in the try block. And you can use more than one catch blocks after the try. Why? Because in your program there can be more than one kinds of exceptions. And in the catch block, you can use one catch block. You can associate a catch block with only one kind of an exception. If you have more than one kind of exception that are likely to be happen in your program, then you have to define more than one catch blocks to deal or to handle those kind of exceptions. So, for example, going back to the same the file read. So now if I uncomment this, okay. So of course you can put this code also within the try block, but this is not the code where exception can happen. The exception will happen when you try to open a file. Okay. So in this case we have written the code over here, and the file that we are trying to read is the readme.txt, which exists in the same folder. But if I just change this name, simply like read, and then if you try to run it, I get an exception because it could not find no such file or directory. Okay, because in this path you have specified the path source lecture 4 exception, whatever the path you have. If the path and the file is correct, and if you run it again, in that case it just reads from the file and display the contents. But if there is any problem in the file, either in the file name or in the file path, then when you execute this code, so now we have written this try, and in the try block we try to open a scanner object on this file for which we have defined the path over here. However, that there was no such file existing, so the Java runtime system will throw an exception. What kind of an exception? You can find out in the information from here. File not found exception, java.io.file not found exception. It could not find the file, and it also then specify the path. And after that, from the here, it will skip all the further lines, and the control will be shifted to the catch block. And in the catch block, you have to specify the type of the exception that your program can handle. File not found exception is a subclass of IO exception class. So you can either use the parent class, or instead of parent class, like I did before, when I was using the throw statement, you can here write file not found exception. Okay, and then because when there is a problem, the Java runtime system will throw an exception, and throwing an exception means it will create an object of that exception class. So in this case, the exception that is related is to the file not found. So it will create a new object of file not found exception. And then if you have, for example, in this case, we have defined a catch block. So maybe we can write here like syso inside just to show you that catch block. Here you can put whatever code you want to handle that kind of an exception. So right now I'm just using the print stack trace. The print stack trace, it's a method for the exception classes. Okay, it's defined in the throwable, the primary, the parent class of all the exception classes, and that provides you the whole stack trace for the methods in which exception has happened. So for example, it's also very important that you define the catch block in a right way, matching to the exception that relates to the code. So for example, in this code, you are writing something that is related to the files. So it means that you have to take care of the similar exception. If you have defined a catch block with an invalid exception class, then your catch handler will not work. So for example, if I write something like here, arithmetic exception, okay, it will start complaining. You have not provided a right exceptional handler for the code that is dealing with the file exception, file not found exceptions, or the file related exceptions. Okay. And maybe I have an example to show you multiple exceptions. Yeah. So as we said that you can have in your programs more than one kind of exceptions. Okay. So in this case, I have a code, just a trivial code, which declares an integer array, and then it also involves an operation where it's a division. Okay. And it also tries to access the arrays. So the size of the array is 5, and we know that the indexes for the array will be from 0 to size minus 1. Okay, so if the array size is 5, the maximum index could be 4. Okay, but what I am trying to do over here is intentionally that I am trying to access the array index which is not okay. Okay, so you have an integer array of size 5, and its index values will be from 0 to 4, but I am using an index value 6. So what happens when you run this code? You get an array index out of bound exception. However, now if I do it like this, and this exception, see, before I was doing the division operation 30 divided by 10, so that was fine. But I have written a catch block that can handle arithmetic exceptions, division by 0. However, since there was no problem, so this block was not executed. Catch block was not even invoked because there was no exceptions related to the arithmetic operation. So if you see over here, we start from here, and the first catch block is about arithmetic exceptions, and it just give a warning message. But what we get over here is array index out of bound exception. It means that this block was never executed. Why? Because in our code there was no exception thrown that was related to the arithmetics. However, now I have changed this. It means that now there will be arithmetic exception, and if there is no arithmetic exception, now our this catch block should be executed. Okay, and now if you see, when it executes this statement, here it happens arithmetic exception. So these lines will be skipped because when the statements after that where your program has thrown an exception, all the subsequent statements gets skipped, and the control is transferred to your catch block. So And in this catch block, we have just one arithmetic exception, and then I use the get message method from the exception class. That just give us. But if you see, these two catch blocks are not executed because no exception related to the array index out of bound or any other exception has been thrown. However, I get this out of try catch block statement, and this statement is coming from whatever you have written after the catch block, it will get executed. Okay. So you always have to remember that you can have, to define exception handling code, you can use try catch and finally statements. The code that you have a doubt that it can create an exception or that is likely to trigger an exception, you put it in the try block, and then maybe in your code there can be more than one. As you see that there can be a number of different statements that can lead to different kind of an exception: arithmetic exceptions, array index out of bound, file not found exception. Okay, so there can be a number of different exceptions, and you can have your own exception classes, your own scenarios that can trigger an exceptions. So you can create your own exception classes, and you can have exception handler using the catch block for your own classes. But that catch block will get executed only if the exception has been thrown. If no exception has been thrown, then that catch block will be not executed. But sometimes you want some code that should always be executed in connection with the try block. And for that kind of code, the Java provides us with the finally block. For example, if you have open a file for a reading operation, and then it's a good practice that whenever you open a resource for something, you must close it. If you have opened a stream on a file object to read data, you should not forget to close that file stream. Okay, like if you have learned C++, you might be familiar, because otherwise this kind of resources can lead to the memory leakage problem, or the memory. And the resources, if you have opened a resource and you have not closed it properly, there could be problems in your program. So you must use some instruction to close that kind of streams. So in that case, because if you have put if you are closing it in the try block, so maybe before that statement there has been thrown an exception before the closing statement, and in that case, if an exception has been thrown before that statement, then that statement will not be executed, which means that your resource will not be closed. In that case, you can use the finally block, because finally block will always be executed, whether there is an exception or not. So here we just have a code, another example, just to demonstrate try catch. So for example, in the try block, this code is just an example code where we ask user to enter the two input values, A and B, and if a user enters the value B, we use the value of the B for a division, and if a user enters the value of B equal to 0, it means that it will throw an exception. Okay, but we can catch that exception and ask the user to enter the value again instead of halting our program. So if you see, I am here asking the user to enter the value of B, which I will use as a divisor, but now I have put this statement in the try block, and if the user enters the value 0, so when you try to divide it, there will be an exception, but now I have provided a handler for that exception. Instead of pointing an error, I give user a useful message that 0 is something like not allowed in the value as a value of B, please re-enter the value. And then I have put a while loop. Until a user doesn't enter the positive value, it will keep asking a user that you must enter a positive value. And it's also you can use it, for example, you are asking a user to enter a numeric value, but on the runtime, user can enter something like alphabetic, ABC, or some special symbols. So for this kind of, we have like if you are using an integer to read a value, but user is not entering an integer, so then the program will throw an input mismatch exception. So this kind of scenarios are handled by input mismatch. So, and then you have also another catch. So we have two catches here, because we know that user can enter a 0 value. So in that case, the 0 value will create a divide by 0 exception. And then we also have user can enter alphabetic values, so input mismatch exception. So we have another catch block over here. And in the finally, so for example, if the divide operation did not succeeded in the first attempt because of the 0 value, then we know that we cannot go back to the try, but we can have another attempt in the finally block to do the operation again. Okay, so if you just run this code here, so now for example, enter a value of a, like I enter 6, I enter value 0. 0 is not allowed. Okay, instead of now throwing an exception, we have handled it. And value of b, please enter a positive integer value. And now let's see if I, okay, so it's also catching because I have entered not numeric value. So in this case, it's again throws an exception. Okay, but if you run it correctly, so for example 7, then your program will execute fine. And then I think I have already explained this to you. So if you have a code that can throw an exception, but you don't want to handle it, then you can use the throws keyword together with the method signatures. So, okay, so you can, and like you, in the same way that you can have a multiple exception handler, you can have a multiple catches in your program. There can be more than one types of exception. Like we have seen now, there can be an arithmetic exception, there can be an input mismatch exception, file not found exception. So if you have a more than one kinds of an exception that can happen in one method, and you don't want to handle it, you can specify all those exceptions with the comma separated list. Okay, so you write a throws, and then you write one exception, comma, another exception, third exception, whatever, how many exceptions you need, you just keep on writing after, like here, throws file not found exception, and if you want to specify another exception, you can put it after the comma. And yeah, try with resource. I think it was introduced in the JDK 7. Before, I told you that if you have opened a resource within a try block, you must need to close it, and you can use the finally block. But the try with resource provides you that you can write, you can open a resource in a special way, like this. Try, and then within the parentheses, you open that resource. And if this kind of syntax in Java, we call it try with resource. Okay, and now if you have written the try in this format, then you don't need to close it by yourself. Whenever the program will end, it will be automatically closed. So that's the difference between a simple try and try with resource. So even in this case, you don't need a finally block to close that stream. Okay, so that was something about exception handling. And now the second part, the second thing that is related is unit testing, and we will use a special API that is provided by the Java, the JUnit, and we will see how we can use the classes from the JUnit to make sure that our program is maybe exception free, or well, it's quite hard to write a program that is 100% exception free. There is always a chances of having possibilities to have an error, but at least testing can give you some confidence that you have tested this program, and it will not break very easily. It will perform quite well under these scenarios or under these conditions. Okay, so maybe we take a 10 minutes break, and then after the break we continue with that. Anton, it's not working again. I mean, it's working, but the mix screen is not working.
Okay.
Not even the screen thing. It's only the camera main is.
It can. Oh, is it on your?
Sorry, no, it's not on mine. Yeah, it's fine. Okay, so in the second part we will learn about software testing. So, and we'll see why it's so important and how we can write our own test classes in Java to test. So, basically, I mean, simply, I hope you will be already familiar with the concept of at least have some introduction. And this lecture is also kind of an introduction about unit testing in Java. The basic objective of testing is to identify the problems and the errors in your code. And if you can identify the errors or the problems, you can fix them. So, so the basic definition is, here are some definitions about what is the software testing is, and the basic idea is of the testing is like to make sure that if you have written a code, for example, if you've written a method or a class that sorts the data, but before releasing it to the customer, it's just like any other product. For example, if you have designed a chair and before delivering it to the customer, you would like to test it. If it's durable, comfortable, and all those things from performance, quality, and things like that. Does it perform the desired functions or not? So the same is true for the software. So if you have written a code, if you have developed an application, so before and not even before, maybe even during the implementation when you are developing, it's recommended that you should keep on testing your code that you are heading in the right direction. Otherwise, I mean, if you have spent days or weeks or months on something, and in the end you found out that this is not what you needed, so that can be a big loss for you, both in terms of money and the time. So the basic objective is that you should test it, that whether the results that are produced by the code are the same that you want. So if you want a sorting in ascending order, it could be that the code that you have written is doing in the opposite way, in the descending order. Then it's not a good thing. And it's also sometimes the code it's performing the functionality that you needed it, but maybe if it's like a performance critical system, it could be like the customer wants something that can solve a problem maybe within 5 seconds or 5 milliseconds, but your application is solving the problem, but maybe it's taking too much time. So these kind of the different tests that you can perform, that whether the basic goal of the testing is that to make sure that it satisfies the requirements that you have. So it's one of the development phases. So we have a different development phases like requirements, design, implementation. And if you ask about the testing, so the testing is normally it's performed either as a part of implementation when you are developing a code, or as a maintenance. So sometimes when you find some problems, and you want to fix that problem, so if you have and then you have written an update, and then you need to test the updated code as well. But it could also be done as a part of the design. And nowadays we have like agile programming practices where even you can start working on the testing before writing the code. Okay, so that's the context where software testing fits in the development process. And when we talk about the software system, so if we look about the structure of the software system, so we have different subsystems and the components and and at different level of granularity. So you might have, for example, if we talk about a system developed in Java, so we have different kinds of components. You can have modules, you can have packages, and then within the packages you can have classes, and inside the classes maybe you have different methods. So it means like the software is usually, it's not like a one big component. You have like several different subsystems and several different components. And similarly, you might have different kinds of testing. So you might have a unit testing that you use to test maybe the basic units or the components in your system. And then it could be like you have developed, for example, if you have developed a software system which is composed of like 10 classes or 10 different components. Maybe those components work fine individually, separately, but when you combine them, it could be that you combine them in a wrong order. And then when those components together as a system maybe doesn't perform the correct function. So you also need an kind of system testing or an integration testing. So where you test all the components together as a one system. And we have if you talk about software engineering terminology, there is also like some other terms that we use, like alpha testing, beta testing, and also regression and performance testing. So alpha testing is you as a software developer as a company, the testing that you do at your own end without involving the customers. But sometimes you also test the system with using the actual customers. So this kind of testing is like a beta testing, and the regression testing is, as I said before, I mean, if you have developed a system, but after maybe some time, like 4 or 5 months, or you find a problem in your software, or maybe there is need to be an update. There are new features that need to be added. So you change your code, and whenever you change the code, it's important that you should retest the program, because now you have added the new features. So even the software that you have developed and tested may not work after the update because of the changes that you introduce. And then we also have some other terminologies like black box, white box, and independent testing. Okay. Well, I mean, independent testing is quite simple. Like, I mean, it's like if you have written an essay in any language, and if you test it yourself, maybe you will not. If you read it yourself, you will not. It will be difficult for you to find out the mistakes in your text. But if you give it to somebody else, it will be much easier for him to identify the problems. So we often write a report, and it looks fine to us, but when a teacher looks at it, it finds out a number of problems. So it's the same like if you're working as a developer in a company, and maybe, of course, in the best of the world, you can do some independent, like you can hire a third party that can do testing for you. But if that's not possible, maybe you can ask some of your colleagues, some other team member, that he can test your code. And then we have a black box and the white box. As the name indicates, the black box is when you don't have an access to the code. It's only you have an access to the interface of the code. You only know that what is the input and what is the output of that code or the component. But if you have an access to even to the code, where you can test even not only the interface but the individual statements or maybe the parts of the components. So that kind of testing is like a white box testing. And as I said in the beginning, I mean, the testing doesn't mean that if you have tested a code, it doesn't mean that it's like 100% error-free or there is no problem. So, no, even a tested code can have a problems. But then the question is like why? I mean, why we should even bother about testing? So the basic objective is like by testing, I mean, you can have, you can say that you can make some claims like, okay, I have tested this code and we know that under these scenarios, it will perform well. It will not break down over this. So you, for example, you can do it for the performance, and you can also use it as a benchmark or as a statistics to market your software that you have. It's a well tested, and we have tested this code under these scenarios. Under, for example, like when 1,000, 2,000 users accessing this code simultaneously under these scenarios, that traffic and for this, bandwidth of the internet, we have tested and it works well, and with these kind of resources or the processor. So, and then I mean, another important question could be like, when should you do the testing? It could be obviously there could be like, I mean, three major options. So one option is that you do it when you develop, or maybe you can do it after the development. And nowadays, a more popular approach, which is related to the agile software development, is like test-driven development, and where you write even the test cases even before developing your code. So each of them have their own merits and the demerits. So for example, I will say that testing after the development is a kind of old-fashioned approach. So nowadays it's hardly recommended and not followed even well. Maybe some beginner-level programmers, of course, learning them can use it. But most of the widely used approach that has been in the industry is you test it while you are developing. So when you write it, when you develop a component, so maybe you immediately after that you test it. Okay. And before implementation, those who advocate the agile practices, stream programming, and they are the advocates, or they like this test-driven development. So, and the benefit of this is like they claim that it helps you to think about the problems and the scenarios beforehand. So, and then you can it gives you a better idea of your system, and you can think about that what kind of situations the system will be working on, so that it helps to write a better kind of software to improve the quality. But the general, the guideline is what you can use either testing when you develop or maybe even before. However, a general practice is that you should not delay the testing process. The more you delay it, the more the cost it will be. So if you find out a problem if you find a problem in the early stage of a development or a project, it's likely that you can fix it with a less cost and time. But if you identify something at the later phases when the software is about to release, then it will be a bigger problem. And then we have some general guidelines over here. So if you are going to test a software or a component, you maybe better need to plan and design your test cases. And a general guideline is that when you are designing a test case, you should try to identify the features, what are the different functionalities that are performed by your piece of code. So if you have identified the features, so features are like, for example, if you take an example of a social media application like a Facebook, so we have a different features. So you can comment, so you can post, and you can share. So these are like different features. So, and for each feature, so at first you identify the features for your application or your software system, and then you identify the input, what kind of inputs for each of the identified features. You need to identify the input data. So, for example, if it's like mathematical applications. So that performs plus, minus, and these kind of operations. So you can identify what kind of values. So if it's like a data structure that you are implementing in your assignment, so what kind of values it could have, and what could be the output for those set of values. So you need to identify the input, and you need to identify the expected output. Okay. So for example, if it's like a simple sum method, so you know that it takes 2, and 2 plus 2 should be 4. So 4 should be the output, and then you use this this input and output to test the code. So if you have expected value is 4, if your method returns the 4, it's fine. If it doesn't return the 4, then it means that there is something wrong. And and then so we have talked about different kinds of tests in the beginning, and one of the basic kind of testing is the unit testing that we use to test the basic units. And when it's come to, there is no standard definition of units in terms of Java. So it could be a package, but normally we have testing at the level of methods in Java. So if you have written maybe in your class or in an API, if you have 5 different methods, so maybe you can have 5 different test cases to test each of the methods. Okay. But it could be, anything from a data structure, algorithm, or maybe a method that you can treat as a unit. And for the unit testing is, the goal should be like, okay, you should you should design a test that can, in the end, give you a guarantee that the component is actually performing the functionality that you want from it. So it's not like you have written it for something else, but it's performing something else. You can do, and then you need to decide that when should you perform the testing, and who will perform the testing, and what kind of testing you need it. So these are the kind of basic questions that you need to identify and answer when you are planning and designing a test case. Okay. So for example, if it's for the unit kind of testing, it's normally the developers who writes the code. He is himself testing the code. So it means that if the developer is testing the code, it means he has an access to the code. So this kind of testing is more like a white box testing, so where you have an access to the code. So then we have an example. So, and as we say that if you have a method, so for example in this case we have a sorting method, so which takes an integer array, and it returns the array in a sorted fashion. It's almost impossible to test this kind of method for all possible input data. There can be like an array can be a size 1, 2, 3, 4, 5, and for each size there can be a number of different combinations in a factorial manner. So you cannot test it for all the possible combinations. So then what can you do? So you need to identify, you need to come up with some testing strategy. Okay. And the testing strategy means that you need to identify the most important or the most critical cases and the input values that are most likely to be used, and where a program is likely to be to perform badly. So, okay. So these kind of testing, for example, if you have if you want to test this sorting method that takes an integer array, so normally when we are writing a code, we write a code for obvious cases, for more standard cases. Okay, it's often as a student we forget the extraordinary cases. We do it for the ordinary cases, but we don't test them for abnormal kind of things, like for example empty list. Maybe a user calls your sorting method to do the sorting operation on an empty list. Your method performs well when it's a non-empty list, when it has a values. But if it's a non-empty value, but it could be trying to access an element, but there is no element that exists. And then sometimes some algorithms perform differently on if it's an even size list or if it's an odd size list. And then it's also like we can identify the extreme cases, like the very large values. So these are some recommended suggestions when you are doing your testing, that you can do it on empty list, a list that contains only one value. That's like a minimum on one extreme, and then on the other extreme, that you can have maybe a very large number of values. And it's also, I mean, known in the testing community that writing a test in itself or implementing a test in itself is not a big challenge. The big challenge is to come up with the identification of the problematic values. What kind of values that can lead to problem? If you have been able to identify the problematic cases, you are most likely to test. I mean, then it's most likely that your program, you can fix those cases, and your program will perform well in all kind of different scenarios. So to sum up this, like a suggestion is that even when you are writing your assignment, so if you have written a method for one kind of requirement or a part of an assignment, so maybe it's a good practice that immediately after developing a method, you write a test case and you run it and make sure that it works for that. Okay. And this testing, I mean, before one of the common practice that we use as a student is that we use system.out.println to test our codes. That could be one way of testing, but that's more like I mean, manual kind of testing, and then you can use debuggers, things. But nowadays, thankfully, we have various tools that automates the testing process. And one of the most widely used testing tool in the Java community is the JUnit, which is kind of a framework plus a tool that is nowadays comes integrated with many of the Java IDEs. For example, Eclipse. In the Eclipse, you don't need to download or install anything. If you have downloaded the Eclipse for the Java, it's already there. You just need to maybe add to your project settings. So for example, if you have to, if maybe it will be more easier if you look at the example in the Eclipse over here. So we have written a simple math class with just two methods. The one method is doing the multiplication, but instead of doing the multiplication using the simple multiplication operator, we use recursive addition. So because the multiplication is simply adding the number again and again, the number of times you multiply it. So, and then we have another sorting method. And if you want to test it now, that whether you are these two methods in your math class, do they perform the functionality in a correct way or not? Then you can define your own test class. Okay, and so here we have written a test class. So now we will look into the details. If you see, if you look at on this code, I am using this package statement, importing a test class and then the assert class. This is one of the two widely used test classes when you do the unit testing. You need the test annotation, and you need the assert statements. Otherwise, if you look at this code, the structure for this test class is almost the same as you have for the ordinary Java class, except that we don't have any main method over here. And by convention, if it's a test class, it should end with the prefix test, because then it will be easy for you to document and identify that this class you have written it as a testing purpose. Or maybe you can organize your testing classes in a separate package. And then we have this at the rate of test. But before that, maybe it's important that so now I have already these JUnit kind of things in my. Maybe I should try to remove them. Okay. So now it's just like a simple Java project. So okay, and you should see that I am using this @test annotation, and then some assert statements. We will see what these assert statements are and what we are doing over here in a short while. But before that, and I'm also using this import statements. But the Eclipse is not, the Java compiler is complaining because it is not able to find them. This is why, because this is the JUnit is not a part of the Java API. It's a separate framework. It's a separate API that, however, you can add it, and you can do this by right-clicking on your project, and then you can configure the class path. There can be different number of different options, like you can add external libraries, you can use add libraries, and then you can use the JUnit over here. And nowadays the recent version for the JUnit is 5, but it's fine if you use the JUnit 4. It's I mean, for this course even the JUnit 4 will work. And then if you click on the finish, so all those things have gone, because now you have all those the JUnit API classes, they are on the class path to your project. Okay, now going back, so we have this multiplication method that takes two integer values, and it returns the result of the multiplication. And when we was talking about the unit testing design for the test case, we talk about that you need to identify the features, and for each feature you need to identify the input and the output data. So in this case, this method multiplication is the feature, and for this feature we need to identify the input, and for the input each input we need to identify the specific output. And then we can use the assert statements from the JUnit to verify that your feature returns the expected value when you give it this input value. So for example, we have identified, you can identify these problematic cases are the fixtures that we call the input values. So maybe you can, like, how does it performs when the two operands are zeros, or maybe negative, or maybe the positive, and also you can do it for the higher values. Okay, so if you go into here, forget about this part over here for a while. In the test class, in your test class, you can define more than one test methods, okay, and then you can use those test methods as test cases to test different features in your software or in your class. And to tell, if you look at if you ignore this part for a while, if you look at the syntax of this method, it's almost the same that we have for the ordinary methods. The new thing over here is this annotation @test. And the annotations in the Java, they are like kind of metadata. So these are like specific instructions, and that they are not a part of, I mean, of course they are a part of the program, but they are not something that we are trying to output or print or to give as a part of the problem. But they are more specific for the compiler. They are not for the user. Okay. So, and whenever you put this @test annotation before a method declaration, that method will become a test method, and your JUnit will treat this method as the JUnit API will treat, and the Java virtual machine, the Java compiler will treat this method as a test method. Okay. So, and then in this test method, and also, I mean, maybe it's also important that if you look at JUnit API, maybe for example, no, not this one. In the JUnit API, you can see all the different the classes and all other components. But now we are talking about two of them, the test and assert. So you can read about the description about this test class, okay, the test annotation, and you can read about what are the different elements that can be used. So for example, now we are using this expected together with the test annotation, and when you execute this test method, if there happens some problem, if some of the statements, if some of the assert statement fails, then this test method will throw an exception. But if you know that you are testing a method for an exception, you beforehand you know that there will be an exception, so you can specify this expected thing, that we are expecting that this method, because sometimes there is a requirement that if a user enters a 0 value or a value out of the index, then your program should throw an exception. So in that case, you want to test this functionality, that whether your program throws an exception or not. So you can do this using the expected things. Okay, and then, for example, if we look at our code for this my math, here we check this second parameter, the second argument b, and if the value of b is less than 0, because this recursive this algorithm, this method, it will work only if the value of the b are positive. If they are not positive, if there are negative values, then it will not work. So then we are checking that if the value is negative, then it should throw illegal argument exception. The second argument parameter must be non-negative. It means that when we use this method, it should throw an exception when the value of b is less than 0. Understand? And to make sure that, and to perform all these kind of testing, we use the assert statements from the assert class in the JUnit. And in the assert class, we have a number of different methods that we can call to test the output of the method or the output of the component that you are testing against the given input values. So if we see over here, you can see a number of different assert equals. And for example, if we see this assert equals, it takes two parameters. The first parameter is the expected value, and the second parameter is the actual value. What does it mean? It means the expected value is the value that this method should return, and the actual value is the value that this method is actually returning. Okay, so now if we go here, assert equals, we know that if we multiply 0 with a 0, what should be the return? What should be the expected output? It should be 0. So this is, we have specified as a 0. It's the expected. And what this method returns, actually, we will get it when we call it. And the same goes on. In this case, if you run it now, you can run it and when you run it, you get a different output than a normal Java application that where you have a console window. Here you can see that this execution unit, you have two different test methods, and you have executed both, 2 out of 2, and there has been no failures. Okay, if a test case runs without any problem, you will get a green. But now I deliberately, for example, I just enter a value here like 10. I'm just making a mistake by myself. So just to show you that if it's a problem, then your JUnit test will complain. Okay, it will give you that information that expected was 10, but the method returns 0. Or maybe, for example, instead of making a mistake over here, if I something do incorrect in the method itself, and again run this code, okay, you see that it gives you a problem. We can have a different kinds of assert statements within a test method. If you want to test whether the expected value is the same as the actual value that the method returns, then you can use assert equals. Okay, and assert true means sometimes if you want to test for a condition, if a method returns a true value or a false value. For the Boolean, the method that are returning, or if you have a condition that you want to test, then you can use assert true and assert false if you want to test it for the false value. And then if you want to test whether an object it has a null reference, then you can use assert null. So you can have a different kind of testing. And if you want to test that whether the two object references point to, so here the difference is that if they have the same values, if you want to test the two values, that the values are primitives or maybe the objects, if the objects are equals, then you can use the assert equal. But if you want to check their reference values, whether the two reference object references are pointing to the same objects or not, then you can use assert same. On the opposite way, you can use assert not same. And if you want to test the arrays, you can use assert equals array method. So basically, what you need to know is that to write a JUnit test, you need this test class, and you need the test annotation, and then you need a combination of different assert statements. And as you are now doing the assignment 2, where we have asked you to do the testing, and for the testing we have specified you some requirement that you should do it for the extreme cases and for test for the correctness. So you can come up with all those. So here, so for example, by this assert equals, I am checking this multiplication that when the values are 0 and 0, does it return the correct value or not? Here I am checking it when we multiply 10 with the 0, 10 with the 1, and 0 with the 10. Okay. So what if I give a negative value here? If the negative value is here, the second parameter is the negative. If we look at here, it will come to the B, and we have this connection. It should throw an exception. Now see, does it? We can test it. I have commented this code for a while just to see what happens. Wait a minute. Illegal argument exception, second parameter must be non-negative. Okay. But I know that this is not a problem. This is what I want from my function, that whenever the user enters a negative value, it should throw an exception. So for me, this exception is okay. This is what I want. So in this case, if you want to your unit test, JUnit, to ignore this kind of things, you can specify this as an expected element. Now, and also, if I remove this test annotation, now I have two test methods here. One of them have a test annotation with it, but the other one does not have. So if I try to run it, only one of the methods has been executed, not the other one, because now the compiler does not treat the other method as a test method. So, and we have, other than this test, we also have some other annotations. For example, we have this before clause, before and after. And also we have an after class annotation. Sometimes we have some specific instructions, maybe a setup kind of things, that we want to execute before a method executes. If you want something to get executed before the method executes, then you have to use before class annotation. And if you want to run that method after all the methods have been run, then you can use after class annotation. And if you want to perform some operation whenever a method executes, then you can use simple before. So for example, we have some simple code over here, a trivial example with the JUnit demo. Okay, in this test, we are not actually testing anything. I'm just trying to show you the hierarchy, the setup in which the different methods in a JUnit test executes. The before class, this method will execute only once when you run the test. After class, it will run only once when all the tests have been executed. So maybe doesn't matter if you have specified it in the beginning or in the end. And then we have a before. This, if you want to execute a code that should execute every time when a method should run, then you can put it with the before annotation. So for example, in this class, can you tell me I have how many test methods? We have 3 test methods. Yes. How can we find out that? Through the @test annotation. Because if you have put the @test annotation method annotation before a method, then that method will become a test method. And in this case, these 3 are the test methods where I am actually doing the testing. I'm telling the compiler that these are the test methods. And the other things, before, after, before class and after class, they are kind of like helping methods that you can use to perform additional tasks. Before and after will execute every time when a test method executes. Every time you execute this test method 1, before it, this setup method will execute. Why? Because I am attaching this annotation with it. And this after, it will execute after every test method executes. So now, if we try to run this, Okay, you can see before class it executes in the beginning, one-time setup. Before it executes before the test method 1 and after the test method 1. And then again, when you run the test method 2, the before executes again. And the after also executes. And then you run test method 3, but before that, so you can see it from here as well. So we have 3 test method 1, test method 2. But if you can see over here, before class executes once, before any method, after class executes one, after all the methods have been executed, but this before and after execute every time when a test method executes. Is it clear? Yeah, this is just the sorting example that I used. It's a code, and then you can write the different test. So for example, if I go back, and also another important thing is that with the assert equals, you can have 2 different versions. In the one, for example, here, I am just specifying the expected value and the actual value. But if you want to specify a message that if this assertion fails, I should get a meaningful message, then you can put that message as a string before that. So for example, here, I say that when we multiply 10 by 5, it should return 50. But if this test fails, then I will get this output as well. So for example, if I give it like this, yeah, I will take your question in a while. So if I run it now, sorry, I need to enable this. Yeah, but it's not an exception, so let's see. I'm deliberately making an error, so.
-5.
Yeah.
That's fine if you are good.
Yeah, but I have already marked the expected over there. It was not a problem because I have marked it as an expected expression. Yeah, you have a question.
So you don't specifically expect the legal argument exception with the assert equals. What if you have other exceptions?
Yeah, then you can specify over here.
Or if you have, like, if you have more than one in the same method, if you expect, you might expect a different exception.
Yeah, that's a good question. I'm not sure that if you can use comma separated list or not, but you can check that. So if you have a more than one, either you can write more than one test methods, or you can use maybe the comma separated list. And then we have, just to give you a more example of, we have a bigger example where we are testing, doing the test. So for example, you have an interface with the name of intlist, and this is kind of maybe similar to those one of the tasks that you are implementing in your assignment. And in this task, in the interface, we have different methods: add, remove, get, size, index of, sort, and you can read about what do these different methods do. And then I have a class that implements this integer list, okay? And I have defined the add, remove, and all those different methods. But now I want to test that whether this class works fine or not. Do these methods are doing the right operations or not? So what I'm doing in this int list test is I have written different test methods, and I have also written a setup method. Just this setup method, in the setup method, because we know that this before method executes every time when you execute a method. And in this method, I am just counting how many tests I am executing. This is just to demonstrate that this method will execute every time. And then in the tail down, just simply that this test has been executed. Then I have a test init size. In the init size, I'm just testing that how does my implementation performs when the list is empty. So the size is 0, and if the size is 0, does it return the same value or not? Okay, so I have created a new list. It means the size should be 0. And then I just execute it. Okay, because if it's an empty array, if it's an empty list, the size method should return, expected value should be 0. So by this test, I can check whether this size method works fine or not. Then I want to test the add and get methods of my int list implementation. Size method returns the size of the current list. So I created a new list, int list, using a special private method build that creates just, in the build method, I just give a size parameter, and then this method returns me a list of specified size. So you can use your own private methods as helper methods. And then in the add and get, I just, if I have created an array, a list of size 5, then it should, the size method should return the same value. And then I'm also, in this method, I'm also checking the get method. Does it return the correct value or not? Okay, how can I do it? So I have created a list 2, and then I use a for loop. If you see how I'm creating this list, I'm using this build method, and in this build method, if you look at the code here, it just takes a size, and then it runs a loop from 0 until size, and initialize and adds the elements equal to those values. So from 0 until size. Okay, so if the size of the list is like 5, the elements in the list will be from 0 to 4. And if the size of the list is 10, the elements in the list will be from 0 to 9. That's, just an example functionality, but you can add any element that you want. So it means if I use a get element for the first time, it should return the element 0, the same as an index. And also, if I've created a list of size 10, it means the maximum index I can get is 9, and the minimum I can get is 0. But if I try to get something like -12, then this method should throw an exception. And I am catching this exception using the catch block. And one way we saw that for the exceptions was that we can use the expected equal to check the exceptions. The other way, maybe you can use this way to check more than one exception as well. If you have multiple exceptions, and if the Java does not allow you to have a comma, you can use this way. And in this way, you can use the catch and you can use a boolean as a flag, and you can set it, you can change its value when the exception has been thrown. You got it or not? Maybe Charles can explain you after that, or maybe I can explain you after the lecture. It's like you have a boolean value. You want to test that whether a method throws an exception or not when the invalid argument has been passed. Okay, the list we have, the size of the list is 10, or maybe we are using the list 1, and what is the size of the list 1? The size is 5. Okay, so what the maximum index in this list will be 4, but if a user specifies more than 4, like 10, size of the list is 5, but the user gives an index value as a 10, which is not okay, then your code should throw an exception. And you catch an exception, and you set the value of the flag as a true, which means that exception has been thrown, and now you have caught it. If it doesn't, for example, if you go to the code and the code of the list, let's say, now I go to the get, I just comment this part. It means that it should not now check the index. And now if I check this code again, and if I run it, okay, the test has failed. Why? Let's see. It says like we have an assertion error because we are trying to access some size which is not in the range. But on the other hand, if you have specified, if you have checked the index, then this should not be a problem. So let's see if we check that, if you run the test again. Now all the tests have run without the problem. Okay. I suggest that I will upload the example code and the lecture slides after the end. So you just play with them, and if it's still you have a difficulty with understanding that, maybe we can help during either the lab sessions or maybe on the Moodle. Yeah, I think I have already covered all these things. And the annotations, yeah, as I told you before, that these are like special tags or the metadata, and these are the instructions for the compiler. That these are the special, and we have already seen, I think, some of the other annotations when we were learning inheritance, like for example override, that tells that this method is overriding the method in the superclass. So just to conclude today's lectures, so here are some general suggestions for your assignments and all the other works. Whenever you write a code, you write a method, try to write a test for that and test it immediately. And you don't need to test for all the possible combinations because it's not feasible. Just test it for a few standard cases, not for just for standard cases, but also for the extreme cases. And then you can use, to generate the input data. I mean, it's one way is that when you run the test, you can provide the input by entering the data by yourself. The other way is that you can also write your helper methods that can provide the input data to your code. So, and then we have some suggestions for the further reading. So you can read about more details about exception handling and unit testing. And of course, as I said, that if you still have questions, use the lab sessions or maybe the Moodle to ask the questions, and we will be happy to help you with that. The next lecture we will be talking about data structures. So until then, if you have any questions, of course, we can take them now. Other than it's a bye from me, and Charles will take over from now. Seems it's not working from here, so you have to do it
Ah,
from the